Hello everyone, welcome to Maths tutorial. This is tutorial number 1, vector calculus. We'll start with question number 1. Find a unit normal vector to the surface x square plus y square plus z square equal to a square at the point a by root 3, a by root 3, a by root 3. First of all, I'll assume this surface to be equal to a variable phi given by x square plus y square plus z square is equals to a square. Now, in order to find out normal vector, I'll first of all find out the gradient of this function phi, which is given as del phi by del x in I direction, del phi by del y in j direction, and del phi by del z in k direction. Now, for finding out del phi by del x, del phi by del y, del phi by del z, I need to differentiate the equation of phi with respect to x, y, and z respectively. So when I differentiate phi with respect to x, I'll get 2x I. Similarly, when I differentiate phi with respect to y, I'll get 2y j. And when I differentiate phi with respect to z, I'll get 2z k. Now at the given point, that is at point a by root 3, a by root 3, a by root 3, the value of this directional derivative will be equal to 2a by root 3i plus 2a by root 3j plus 2a by root 3k. So this is the normal vector that I have obtained. Now I need to find out the unit normal vector. To calculate unit normal vector, we need to use the magnitude of this normal vector. So we can write it as nebula dot phi over mod of nebula dot phi. Now to find out the magnitude of any of the vector, we take the square of individual terms of the vector and add them up and then put them inside a single under root. So over here we'll get 2a by root 3i plus 2a by root 3j plus 2a by root 3k whole divided by, I'll take the magnitude of this vector, which will be the square of x component, that is 2a by root 3 square, plus square of y component, that is 2a by root 3 square, and square of z component, that is 2a by root 3 square. Now in the numerator, I can simply take down 2a by root 3 as common, so I'll be left with I plus j plus k, the 3 unit vectors, and in the denominator also I can take this thing down, so I'll get 3 times 2a by root 3 square. On squaring the denominator, let me do it separately. I'll get 3 times 4a by 3, 4a square by 3, for which the 3 will get cancelled and I'll be having root of 4a square, which on solving will become 2 of a. Right. So this I can write down as 2a by root 3 I plus j plus k over 2a, which further get cancelled to give 1 by root 3 times I plus j plus k. This is your final answer. Now let's look into the next question. In question number 2, you're supposed to find the directional derivative of phi of xyz, xy square plus yz square at the given point 2, minus 1, 1 in the direction of the given vector I plus 2j plus 2k. So first of all, I'll find out the directional derivative of this function phi. So the directional derivative, as we have seen in the previous question also, it is given as del phi by del x in the I direction plus del phi by del y in j direction plus del phi by del z in k direction. Now I need to differentiate the function phi with respect to x, y, and z respectively. So first of all, when I differentiate this function phi with respect to x, this term will become constant. So I'll be left with differentiating this term, which will give me y square. Now when I differentiate this term with respect to y, I'll get 2xy plus z square. This whole will be multiplied with the vector j, and the third one, when I differentiate this phi with respect to z, the first term, it will become constant, and I need to differentiate the second term only, which will give me 2yz of k. Now at the given point, that is at 2, -1 and 1, the value of this directional derivative will become -1 square I plus 2 times 2 into -1 plus 1 square j plus 2 times -1 into 1 k. What I have done is I have substituted the value of 2 minus 1 1 in the equation of this directional derivative of phi. So on solving this, I'll be getting I plus -4 plus 1 j minus 2k, or simply I can write it as I minus 3j minus 2k. Now in the direction of this vector I plus 2j plus 2k, first of all I need to find out the unit vector in this direction. So let us assume that this vector to be equal to a. So I'm assuming this vector to be a. So the unit vector in the direction of a will be given as a cap is equals to vector a over mod of vector a, which is I plus 2j plus 2k over mod. Basically means we are calculating the magnitude. So I'll be squaring individual terms or individual components, and I'll be adding them. So 1 square plus 2 square plus 2 square, and this will be kept all together inside the under root. Now next I'll be solving this up, so I'll get I plus 2j plus 2k over 1 plus 4 plus 4, which will result into 9, and as we know the under root of 9 is 3, so I'll be left with I plus 2j plus 2k divided by 3. Now in order to find out the unit vector directional derivative in this particular direction of unit vector a, we can simply multiply this directional derivative, that is I minus 3j minus 2k, with the unit vector that we have obtained. So the directional derivative in direction of a will be nebula dot phi. This equation will have a dot product with the unit vector a, which becomes I minus 3j minus 2k dot I plus 2j plus 2k divided by 3. So over here, while taking the dot product, the x component of the first vector will be multiplied with the x component of the second vector. So we'll get 1 over here. The y component minus 3 over here will be multiplied by this y component of the second vector, that is 2. So we'll get minus 3 into 2, that is minus 6. And the third will be minus 2 into minus 2 into plus 2, that will be minus 4. This whole divided by 3 On solving the numerator, we get minus 9 divided by 3, which is equals to minus 3. So our final answer will be equal to minus 3.